morning, students. Chapter 7, System of Particles and Rotational Motion. Yes, you will see some MCQs here. The distance between two particles of masses m1 and m2 is r. If the distances of these particles from the center of mass, CM, center of mass of the system are r1 and r2 respectively, then r1 is equal to question mark, r2 is equal to question mark. Okay. See, first of all, the distance between two particles of masses m1 and m2 is r. So suppose it is first particle having mass m, another particle having mass m2. Distance between them is r. Okay. Now, if the distances of these particles from the center of mass, now actually I don't know where is center of mass, so I am assuming, let here it is center of mass. So, if the distances of these particles from the center of mass of the system are r1 and r2, so suppose from this center of mass, distance of this particle is r1 and distance of this particle is r2. Clear? Okay? If the distances of these particles from center of mass of the system are r1 and r2 respectively, then you have to obtain equations of r1 and r2. Now see, you have figured it is. Okay? Okay. Now how to solve this question? First of all, I will assume this center of mass on origin. Okay, let center of mass is at origin. Center of mass is at origin. Here it is, at origin. So I can say it is positive x-axis, it is negative x-axis. Clear about this? Now, for system of two particles, we have equation of center of mass. Yes, for system of particles, we have equation of center of mass. That is, our center of mass is equal to m1 r1 plus m2 r2 divided by m1 plus m2. Now, question is why to use this equation? Not that simple that x center of mass is equal to m1 x1 plus m2 x2 upon m1 plus m2, because here, see, origin is here. One particle is on right hand side, means on positive x-axis, and another particle is on negative x-axis, means one is positive and one is negative. So you have to take position vector. Okay. Now, let center of mass is at origin. So our center of mass is equal to m1 r1 plus m2 r2 divided by m1 plus m2. So it is easy. See, as center of mass is at origin, center of mass is at origin, I can directly write here how. See, this m1 plus m2 I can multiply here. m1 plus m2. Center of mass, it is at origin, so 0. Center of mass, it is at origin, so 0. Center of mass is at origin, so 0. m1 means here it is m1. m1. Here it is on negative x-axis at distance r1. From center of mass, it is on negative x-axis at distance r1. So here I have to write minus r1 plus m2 as it is. From center of mass, this m2 is on positive x-axis at distance r2. So here r2, yes. This equation is important. Okay, how to write this? Clear about this? Okay, first of all, m1 plus m2 multiply this side. R center of mass is 0. m1 as it is. r1 is equal to minus r1. Why minus r1? Because it is on negative x-axis. r2 it is plus y because it is on positive x-axis. So now this side is 0 is equal to, it is minus m1 r1 plus m2 r1. Okay, so therefore minus m1 r1 this side, so m1 r1 is equal to, it is m2 r1. Okay, so therefore r1 upon r2 is equal to m2 upon m1. Simple. r1 upon r2 is equal to, it is m2 upon m1. Now, how to simplify this? r1 plus r2 plus 1 is equal to m2 upon m1 plus 1. Simple. Both side add 1. Both side add 1. Okay. Okay. Or in another language of maths, you can say take componendo in numerator. Take componendo in numerator. So how to simplify this? See, r1 plus r2 upon r is equal to m2 plus m1 upon m1. Simple. r1 plus r2 upon r2 is equal to m2 plus m1 upon m1. Okay. Now r1 plus r2, see in figure it is clear. Distance between m1 and m2 is r, and if you take addition of r1 and r2, it is nothing but r. So here I can write that therefore r upon r2 is equal to it is m2 upon m1 divided by m1. Now make this r2 as subject. So therefore r2 is equal to this r2 is equal to it is m1r upon m1 plus m2. It is equation of r2. Simple. It is equation of r2. So how to solve such questions? Okay, which concept you have to use, that you have to understand. Okay, and next is yes, it is equation of r2. Now how to obtain equation of r1? Yes, with the help of this equation. With the help of this equation, yes, you have to obtain equation of r1 by yourself, and yes, you will get it. Is simple or easy to remember. Okay, r1 is equal to it is m2r upon m1 plus m upon m1 plus, clear? r1 is equal to it is m2r upon m1 plus m2. Clear about this? Okay, so yes, it is one question. It is easy. Okay, just you have to remember concept. Yes, you have to use concept of center of mass. Okay, now next question. See, you are given one figure. You are given one figure. Okay, as shown in figure, there is one equilateral triangle ABC. Three particles having masses m are placed on corners of equilateral triangle having side L. Okay, you have to find moment of inertia about axis AX, which is perpendicular to AB and in plane of ABC, means in plane of ball. Okay, yes. You have to find moment of inertia about this AX. Now see, here you are given three masses at A, at B and at C. At A, at B and at C. Yes or no? Yes. Then how to find moment of inertia? See, here it is. Here I will write moment of inertia. Moment of inertia about axis AX. AX is equal to, as you are given three particles, I can write this equation as IA plus IB plus IC. It means moment of inertia of this particle about this AX axis, moment of inertia of particle B about this axis, moment of inertia of particle C about this axis. Yes or no? Yes, it is. Now you know that what is equation of moment of inertia? Moment of inertia of a particle is mass into perpendicular distance square. Mass into perpendicular distance square. So yes, here I can write this equation as mass is same, so it is m RA square plus m RB square plus m RC square. Yes or no? Yes, it is. RA, RB and RC. So yes, first of all you have to identify RA, RB and RC. RA, RB and RC, they are distances of A, B, C respectively from AX. So now here I will find. Okay, now perpendicular distance says from axis AX. Chalo, first of all we will find RA. See, it is axis, and A, mass A, it is on the same axis, so its perpendicular distances from figure it is clear, it is 0. Yes or no? Yes, it is 0. Okay, as this mass which is at A is on axis, its perpendicular distance is 0. Now RB. Now how to find this RB? See, yes, here it is B. So from this AX line, yes, it is the distance, perpendicular distance. Perpendicular distance means, see, this distance makes angle 90, makes angle 90 with this AX. So yes, what is its perpendicular distance? It is clear. Now RC, how to find RC? So see, RC, C is here. Yes, C is here. So what is perpendicular distance of this point C from given axis? This? No, because see, it is not making angle 90. Is it angle 90? No. Perpendicular distance means, see, this line makes angle 90 with AX axis. So it is called perpendicular distance. It is called RC. It is called RC. Now how to find this RC? See, here it is. Here it is. This distance is L. This angle is 60. We know that if we find its x component, means this one, means this one, means this one, then it is called perpendicular distance from AX. Now how to find this distance? See, it is angle 60. It is its adjacent side. It is its adjacent side, and for adjacent side, or simple, yeah, what is x component? X component, it is L cos 60. It is L cos 60. What is x component? It is L cos 60. So yes, from this AX axis, perpendicular distance of C is L cos 60. Here it is L cos 60. L cos 60, cos 60. Yes, what is value of cos 60? It is 1 by 2. Okay, so is equal to, it is L by 2. Is equal to, it is L by 2. Clear? So it is RA, RB and RC. Now it is simple. You have to put values. Okay, so is equal to, it is M 0 square plus M L square plus M L by 2 full square. So it is equal to 0 plus ml square plus, here it is ml square by 4. So it is equal to 4 ml square plus ml square divided by 4. So it is equal to 5 ml square by 4. 5 ml square by 4. Yes, here it is, option D. That is your answer. That is your answer. Clear about this? So see, in question of moment of inertia, the most important thing is about which axis you have to find moment of inertia. Okay, so take care about that. And yes, this is how to solve some questions. Okay. Okay, next question, see. A string is wound around a disc of radius r and mass capital M, and at the free end of the string a body of mass m is suspended. The body is then allowed to descend. Show that the angular acceleration of the disc is alpha is equal to mg upon r plus r n plus n by 2. Now see, understand this question. A string is wound around a disc of radius r and mass m. Suppose it is this. Suppose it is disc. Okay, a string is wound around a disc. String is wound around a disc. Mass of disk is capital M and its radius is R. Okay. And at the free end of the string, a body of mass M is suspended. Let it is free end of string. Let it is free end of string, and a body of mass M is suspended. Clear about this? It is disk having mass M and radius R. So read this statement again. A string is wound around a disk of radius R and mass M, and at the free end of the string, a body of mass M is suspended as shown in figure. Yes. The body is then allowed to descend. Descend means this body will move in downward direction. This body will move in downward direction. Okay. So I am assuming that it is moving in downward direction with acceleration A, with linear acceleration A. So first statement I am assuming that body of mass M is moving downward with linear acceleration A, as shown in figure. Now first of all we have to identify numbers of forces acting on the system. Yes, we know that mg in downward direction and tension in the string. So first thing, as this block M, that body of mass M is moving downward with linear acceleration A, that how to write? Yes, I can write Ma, or yes, we know that sigma F is equal to M. This body is moving downward with acceleration A, so I can write sigma F is equal to Ma. Now on this body, there are two forces, mg and T. Then how to write? Yes, it is mg minus T is equal to A. Okay, so therefore it is mg minus M is equal to T. So therefore T is equal to, it is mg minus T. Simple? Clear? Okay. So T is equal to, it is mg minus M. T means nothing. T is tension in the string. T is tension in the string. Okay, T is equal to mg minus A is tension in string due to which disk rotates. Yes. Due to tension produced in string, this disk rotates. See what happens actually. This block is descending. Okay, so yes, this disk will perform rotational motion. For rotational motion, if it is performing rotational motion, then torque is produced. So therefore, torque produced in disk. See carefully, torque produced in disk. Tau is equal to torque. What is equation of torque? Torque is equal to force into perpendicular distance. Due to which force this disk is performing rotational motion? Due to tension. So yes, tension you have to consider as force. Okay, so tension, perpendicular distance from this axis, its perpendicular distance is nothing but its radius, so it is its radius. Simple. So see, torque produced in disk, tau is equal to, it is force into perpendicular distance. Clear? Okay. Now tau is equal to, we know another equation, tau is equal to I alpha. So therefore I alpha is equal to, it is TR. I alpha is equal to, it is TR. To make alpha is subject, so therefore alpha is equal to, it is TR upon I. But it is not your answer. So therefore alpha is equal to T. You know what is equation of T. T is equal to mg minus A. It is mg minus A. I means moment of inertia. Moment of inertia of disk. And what is moment of inertia of disk? It is mr square by 2. It is mr square by 2. Simple? Yes. alpha is equal to, it is mg minus a. First of all, put value of t r as it is, then put value of I. Clear about this? So see what happens. 1r cut. I can write this 2 in numerator. So therefore alpha is equal to, it is 2 m g minus a upon mi. Still it is not your answer. Then how to write? Yes, how to write this acceleration a. See, this acceleration is in this direction. This acceleration a is in this direction, means tangential to disk. So here how to write? See, this linear acceleration a is tangential. Linear acceleration a is tangential to disk. So I can write here linear acceleration is tangential to disk. So therefore a is equal to alpha r. Tangential acceleration, remember starting of chapter, a tangential acceleration a is equal to, it is alpha r. A is equal to alpha r. So here you have to replace this a by alpha r. So therefore from this equation, okay, let write this in box. Okay, so now here alpha is equal to, it is 2 m g minus, a is replaced by this alpha r. It is alpha r divided by, here it is mr. Here it is mr. Clear? Now as you have to find what is equation of alpha, you have to make alpha as subject. Physics over, now it's maths. Okay, so how to find this? First of all, we will cross multiply this. Okay, see here it is alpha mr is equal to 2mg minus 2m alpha r. Take this term here. So alpha mr plus 2m alpha r is equal to 2mg. Simple. Now take alpha r common. Okay, alpha r common. So alpha r common is equal to, in bracket here you have m plus here you have 2m is equal to, it is 2mg. Now make alpha as subject. So alpha is equal to, it is 2mg upon it is r m plus 2m. Simple. Now again it is not your answer. In numerator you have only mg. So take this 2 in denominator of denominator. So therefore alpha is equal to, it is mg upon r is equal to m by 2 plus 2m divided by m, which is only m. It is your answer. Clear? So yes, this one easy question, easy if you know each and every formula, if you know each and every concept. Okay, then this question is easy. First of all, find tension, because due to tension, that is performing rotational motion. So you have to write tension as a force for producing rotational motion. Okay, yes. Then tau is equal to, it is I alpha, make alpha as subject. From this alpha, yes, it is your answer, but you have to obtain this formula. So we know that this linear acceleration is tangential to this, so it is a is equal to alpha r. We know this equation. Put value, simplify, you will get your answer. Clear about it? So yes, this is it for today, and I think this is it for chapter number 7. Okay.